What we're going to do is take these carbon gridded film TEM grids, and we're going to place nanoparticles that are in water on them. We found a method with the use of a copper tape background and ethyl alcohol that diffuses the particles through the grid, and the water goes through the grid and leaves the particles behind. So what we're going to do is take some of this clean room style copper tape, which can be purchased at Ted Pella or any of the other lab companies, and we're going to make a little circular disc that we'll be working on. And we have clean gloves on, and these scissors have been cleaned, and they are the blued style lab scissors, which we recommend. And you go ahead and peel off this backing, and what you'll have is a sticky copper tape that you can place on a sample lid. That's all this is a plastic sample lid. And that becomes the surface that you're going to work on. Now the copper is necessary to change the attractiveness of the nanoparticles and the solutions that we're dealing with as a ground plane. So that's what that's acting as. And you can make a larger one if you want, but this works just fine. We're then going to use a 10 microliter pipette, and 10 microliters is what we found works good with these size of grids. We're going to take ethyl alcohol, which is a 200 proof. This is an HPLC grade, not an Everclear or a 95 proof, or excuse me, 195 proof. This is a 200 proof for HPLC with no contaminants in it. And we've already transferred some into a container instead of taking directly out, so we don't cross-contaminate ever. And we've also taken some of the nanoparticles and already placed it in its little container there. So what we're going to do is take 10 microliters of the ethyl alcohol, and we're going to place it on the copper surface here, make a little puddle. We'll switch tips here in preparation for putting the rest on. And then we're going to take a copper grid that is coated with this type B carbon film, and there is a black side and there is a copper side, and the side you want to have down on the ethyl alcohol is the black side. I'm going to have to take that off and flip it over. And what will happen is it'll float on the top. You can apply it without, if you get it the wrong way around, you're going to have to redo it. We do want it, there we go. So now it's on the surface of the ethyl alcohol. And then what we'll do is we'll take up 10 microliters of the nanoparticles and very carefully lay that on the surface and have it be pulled through to the alcohol down below. Now this isn't working very well, so we're going to do it one more time. You can see as it's being pulled through, it's going to leave behind the nanoparticles on that carbon. And then we let that dehydrate to 50% of the volume of the liquid that's on there. And we're going to do it one more time just because we had kind of a mess with the ethyl alcohol. We'll do one more here. So we take ethyl alcohol. You need a 10 microliter amount of ethyl alcohol. I'll try to be a little more careful with this grid this time. And again, you want to have this with the, nope, lost it. Got it again. These grids are very hard to work with these type of tweezers. There are actually better tweezers than this to have it work. There we go. So the alcohol is underneath it. And then we'll grab another tip. 10 microliters of solution. And you can see how it pulled it right through. See that droplet going right through it? That's what you want to see. And what it's doing is leaving behind the nanoparticles. So that action is what you want to see. The water wanting to go to the ethyl alcohol and having that dilution, the ethyl alcohol is pulling that through the surface of that carbon grid. This is a really good example of what you want to see as far as the liquids going through. And then make note that when imaging this on the TEM, you're going to want to do two areas of focus. One is going to be the central area where you're putting the droplets, and the other is going to be the periphery if you had any runoff in that area. But 10 microliters will give you kind of an idea of how many nanoparticles you're looking for from the count rates you have from the Malvern and the DLS information. And then from that, you should be able to correlate size distribution from your TEM imaging. And if you expose the nanoparticles and there's a change, you should do a DLS as well as a TEM to show a difference in particle sizing if you're looking for a change in the particles themselves. But that's how we've been able to get the best imaging so far with the TEM, is by this diffusion method of having the water nanoparticles being pulled through the carbon film by the ethyl alcohol on the other side. Once this is done and it's reduced by 50% its volume, you take a empty holder. You'll take the grid off from that holder, or from the copper. You'll place it inside of the hole, and then you'll place this inside of a vacuum desiccator to make sure that there's no liquid left on it before imaging on the TEM. But the particles adhere very, very well once they've settled on that carbon film. Rinsing the carbon anytime after that, they don't seem to want to come off. So it's a really good way of getting a good fixing of particles to the surface. So once that's done and you've taken out of the desiccator, you can take that up to the lab and image it on the TEM. But so to recap, we put a droplet of ethyl alcohol on top of a clean copper surface. Then we place the carbon side down of the TEM grids. That is a type B film grid, and have the copper side of that grid facing up. And then we deposit 10 microliters of the sample of the nanoparticles in water on the surface and watch them being pulled through the grid. And then after 50% of the liquid is gone, and that can just be visually looked at, you take the grid off, put it inside of a clean new case for grids, and then put inside of a vacuum desiccator to remove any other liquids, and then it's ready for imaging.